Okay, so we're now at exponent stage. An exponent is a quantity representing the power to which a given number or expression is to be raised, usually expressed as a raised symbol beside the number or expression. For example, a to the 2, 2 to the 4th, c to the 8th, and 10 to the 3rd, etc., etc., etc. The superscripts are in red are the exponents, while those in blue are referred to as the variable or the number. When the same variables are being multiplied, the exponents are added. So if you have a and a or b and b, so look at this. A to the 4th times a to the 3rd is equal to a to the 4th plus 3 equal to a to the 7th. And why is this so? Here's an example. Look at this up here. You have the base number, which is 6, raised to the 3rd power. This is the exponent. And so, because it's raised to the 3rd power, that means there are 3 6's that are being multiplied by. Right? So in this case, you would have had 4 a's plus 3 a's will give you 7 a's, a to the 7th power. A to the 4th times a to the 3rd times b to the 4th times a to the 3rd is equal to all the a's adding back together. So 4 plus 3 plus 3. 4 plus 3 is 7. 7 plus 3 is 10. So a to the 10. Note well that the b did not get added because it's a different variable. So you have a to the 10th, b to the 4th. When the same variables are being divided, their exponents are subtracted. So here we have a to the 4th divided by a to the 3rd, which is equal to a to the 4th minus 3 equal to a to the 1. Anything to the 1 power brings back the same variable. Here we have a to the 4th divided by a to the 3rd power times b, right? So all of this underneath here. The only variables that are cloned and are the same is a. B doesn't have any friends on top. So it will be a to the 4th minus 3 divided by b, which gives you a to the 1st power over b, which in fact is a over b. The equation below demonstrates how to solve for a variable by getting rid of its exponent. So if you have a squared equal to b plus c, if you want to get rid of the square root, if you just want to solve for a, you will multiply the 2 by a half, because 2 is a whole number which is practically over 1. So you will have 2 over 1 times 1 over 2. The 2's will cancel out. And the same thing you do, if you do that for this side, you have to do it for this side. So everything together is raised to the power of 1 times a half. Of course, you're going to see the next video, the corresponding help section of this video is coming up. Okay, so don't feel like, oh my god, this is a lot. No, I'm going to help you through it. Therefore, a will be equal to the square root of b plus c. I'm going to explain this in a while. The above is a rule that must be committed to memory. If the variable a above had been a cubed, the component of a would have been multiplied by a third, and so would have the sum of a, b plus c. For example, a cubed equal to b plus c. If you want to get rid of the cube or the 3, just multiply by a third. And then you have to do the same thing. You have to raise everything to a third on the right hand side, which you see here. So then therefore a will be equal to b plus c raised to the 3rd power. Okay? And here is the end of my explanation on exponents. Coming up right now will be my worksheet. I hope my worksheet helps you. So get ready. Take out your books and let's get ready. Okay? Alright. See you in a bit. Okay, so as promised, here is the worksheet section or segment of the video. So multiplication of exponents. A to the 4th times a to the 3rd is equal to a to the 4th plus 3 to give you a to the 7th. Now why? Why do we add for multiplications? Why? So here's why. If you have 4a to the 4th means that you have 4 a's. Okay? So this corresponds to that. And remember, you're multiplying a to the 3rd now. So you're adding 3 more a's. So this section corresponds with that. So if you add them up, you go 1, 2, 3, 4, 5, 6, 7. So instead of writing them out like this, you would just add them as shown here. So that's why. So here we have another one. In this one, we're going to have to group because we have different variables. We have A, C, and B. So if we group them, we know we have A and A. So you can write it like this. A times A. So that crosses out. And then we could group up the B's. So we have B squared times B. And then we could group up the C's, so we have C squared times C squared. And if you want to make it easy on yourself, you could just do the adding. So you would say A1 plus 1 times B2 plus 1 times C2 plus 2. And from that you would get A squared B to the 3rd power C to the 4th. Now is this true? Yes. So A times A times B times B times B. So this goes here and here. This is for that. Times C times C times C times C. And if you count them, you see A squared times B cubed times C to the 4th, which is A squared B cubed C to the 4th. It's the same thing. Okay? So now let's move on into division of exponents. So with division, you minus. Why? So if you do something like this, A times A divided by A times A, you have 3 A's up here, so cross out, cross out, cross out. So you're basically taking away 3 that was down here from the 3 that was up here in something called cancelling out, and you're left back with A. This is just easier to write than writing out the whole thing. So let's try this one. Now I have mixed variables, and remember each variable corresponds to its own self. So in this case, you would have A to the 4th minus 3 times, that means times, B to the 6th minus 6 times C to the 3 minus 4. And what you would have left back is A to the 1. You don't have to write it, but there. And B to the 0. Anything to 0 is equal to 1. The entire thing is equal to 1. You'll see right now. And then you have C minus 1. Because it's 3 minus 4. So you can have minus 1. So in all, you have A times 1 times c to the minus 1. And so from there you would have a c to the minus 1. Now anything to the minus of a number would be this. So for instance, this in turn will be a over c, because look at this workspace here. 1 over a is equal to a minus 1. Just the same as a minus 1 is equal to 1 over a. So therefore, a minus 2 must be equal to 1 over a squared. Okay? So if I have 3a to the minus 3, then that means 3 over a cubed, because this is actually saying 3 times 1 over a cubed. Got it? Okay? So this will take time to catch on, but you'll get through. I'll show you eventually as you move along. So why did we get a over c? Let's do it long way. You had 4 a's, and I just eliminate this multiplication sign because it's understood. You had 6 b's, and you had 3 c's over 3 a's, 6 b's, and 4 c's. You have 3 a's, so that's left back. 6 b's all cancel because you had the same count down here, and you had 3 c's. And if you look at it, you have a over c. Is it not the same thing? Of course. Yay! Alright, so moving on. Task 3 will be for solving for a variable raised to an exponent. So whenever you have a variable raised to exponent and you want just the letter here, you have to multiply it by 1 over the number that it has. For instance, a squared multiplied by 1 over 2. This 2 is actually over 1, so these cancel out. But because it did this to this, you had to do it to these on the right hand side. Raise it to a half. So therefore you'll be left back with a equals to b plus c all raised to a half. This represents the square root sign. So you would have a equals to the square root of b plus c. Okay? Now here we have a cubed, b plus c. Again, just multiply it. Just multiply it by 1. Just put 1 over the number it is, and put this over 1 here. And then you do the same thing here. B plus c, bracket, bracket, and you raise it to a third. These cancel out, and you're left back with a equals to b plus c raised to a third. Okay? B plus c. I put a little 3 in there. Okay, but more than likely you're going to only have this to contend with. This one with the square root. Okay, let's mix it up a little bit. Felt like it. So Pythagoras' theorem uses a squared equal to b squared plus c squared. And you use this for right angle triangles. And you already know that the a square represents the hypotenuse. B and c would represent 2 legs. So a squared is hypotenuse, which is opposite the 90-degree angle. and represents the hypotenuse. It's the longest side. B and C, it doesn't have, this doesn't have to be B, this doesn't have to be C. It could be C and B, it doesn't matter, but they represent any other leg other than the hypotenuse. So task 1 is to solve for A. So if A squared is equal to B squared plus C squared, we know from on top that to get rid of this square, you multiply by a half, and you put these in brackets and raise it by a half as well. So these are going to cancel out, and we're left back with B squared plus C squared square root that. We want to solve for B now. So we have A squared equal B squared plus C squared. From previous videos, you want to get rid of C and keep B by itself. So you're going to say A squared equal to B squared plus C squared minus C squared. So therefore, you're going to have to minus C squared from here. I put the positive sign here simply because A is positive and C is a negative entity. So you cancel here. We could flip it to the next side and write it in a way it looks pleasing to the eyes. So you could write B squared equal to A squared minus C squared. It's the same thing. And now we can get rid of the square root sign, raise this by square, and we're going to have now B equals to A squared minus C squared to a half. So therefore B is the square root of A squared minus C squared. And now we're going to solve for C. Same idea. So we have A squared equal B squared plus C squared. We want to get rid of B, so we're going to say A squared minus B squared equal to B squared minus B squared. Have to minus it from itself. It goes. So we're going to make it more pleasing to the eyes. C squared is equal to A squared minus B squared. You want to get rid of this square. That goes. So you're going to say C is equal to the square root of A squared minus B squared. Okay? I hope this helps. See you in the next video.